in this video tutorial, we are going to be having a look at the process of smoothing data. Now we want to smooth data within time series data in order to help us identify overall trends within that data across the period of time that it's been recorded for. Now when we smooth the data, what this helps us do is make any really low data points a little less low, or any really high data points a little less high, and overall reducing some of the irregularities that may come with time series data. Once these irregularities have been smoothed, it can be easier for us to identify overall trends within this data. The process that we are looking at today is called a 3-point moving mean, whereby we can take some moving averages of our data using a 3-point system to be able to smooth this time series data. First, we're going to have a look at the actual process of taking the 3-point moving mean. To my side here, we have an example of a set of time series data, whereby we have the time of day in 24-hour time in our first row, and in our second row, we have the temperature at each of those time points. Now, when we are looking at this data, we can refer to each as a certain data point. So this first time of 600 hours can be data point 1, our 800 data point 2, 1000 data point 3, 1200 data point 4, and 1400 data point 5. It's important for us to be able to identify our individual data points because that will impact how we can take our 3-point moving means. Now, like the name suggests, we need to use 3 points at a time in order to calculate this moving mean. So if I was to start here at data point 1, my 3 points would include data point 1, data point 2, and data point 3. And that will help us calculate one of our moving means. You'll notice that this will then give us an average of data point 2. But we're missing out on data point 1. This is because if we try to smooth our data by having data point 1 as the middle, we'll notice that we don't have a data point here prior to data point 1. So when we end up smoothing our data, we're going to end up with our first and our last data points not actually having a smoothed value. So that is just something to keep in mind when we are smoothing our data points, is we are going to end up with 2 less data points than what we had in our original data. So if I wanted to smooth data point 2, I'm simply going to take these first 3 data points, add them together, and in order to find this average, I'm going to divide them by 3. And this process can be repeated for every single point in the data set other than the first and the last points previously mentioned. Now, we're also just going to take a quick visual look at what this smoothing could look like on a time series plot. What I've got here is an example of some time series data, whereby we know we always have time on our x-axis and then our other measurable on the y. And we can see here in the pink points that I've plotted some time series data. And due to the irregular nature of this data, it could be challenging for us to identify what sort of trend this would take. If we were to plot the smoothed data for this time series trend, after we applied this formula here to all of our points except for the first and the last one, we might end up with a graph that looks a bit similar to this one here in our blue. We can see that in comparison to the pink, this blue smooth data is a little bit easier for us to see this overall positive trend within our time series graph. However, like we mentioned earlier, we can see that we've actually lost our first and our last data point in our smooth data. So the more and more points you use to smooth the data, even though we're just using 3, you can also use 5, 7, 9, etc. The more points you use, the more points you're going to lose off each end of your time series graph. So for the sake of getting a easier to read trend, you need to make sure you aren't losing too many data points. So this is our overall benefit of smoothing the data by taking the average and being able to reduce the highs and lows of the data so that we can see our overall trends. Now that we understand the basis of our 3-point moving means, we're going to spend some time having a look at this worked example here. We've been given a table of sales figures, and we've been asked to construct 3-point moving means, each correct to 1 decimal place. We've also been asked in this question to compare the information by plotting both sets of data on the same set of axes and to comment if we can see an overall trend in the data. So we can see up here we have our weeks in our first row, which is our time, and then our sales in the second row, which is what we're going to be measuring on our y-axis. Now you've noticed I've added a third row to my table, and this is where I am going to be putting my 3-point moving mean data. Now when you create a similar row to your table, a top tip that I like to use is that straight away I block out the first and the last data point for that row. That's because we've already explored that with our 3-point moving means we lose our first and our last data point. So by putting these crosses into my table, I ensure that I don't try to accidentally calculate these values, because whatever I do end up trying to calculate won't be accurate in the context of a 3-point moving mean. Now we're going to have a go at some of these data values here, and I'm going to start off by taking my week 2 value and smoothing it. So remembering our week 2 is going to be our center value. So if we want to do a 3-point moving mean, we are considering the point above as well as the point before our week 2 value. So our week 2 smoothed, we're going to take 32, 58, and 45 and add these together. Then to help us find the overall average, we're going to divide it by 3. And this will give us a 3-point moving mean of 45, which will be our average of those 3 values. We're going to repeat this again for one more of our values, and this time I'm going to have a look at week 6 smoothed. Now usually when you're calculating this, you would do it in order, but I'm having a look at a few different data values so you can see how we select the 3 points to use for our average. So having a look for our week 6 smoothed, I can find week 6 here in my table of values. So 6 is going to be my middle value. I'm also going to use weeks 5 and week 7 when calculating this smoothed value. So to calculate this average, I'm going to go 65 plus 50 plus 50, and I'm going to divide all of that by 3. And I can see that that will give me an average value of 55, which I can then go ahead and place in my smoothed values. What I want you to do now is to pause this video and have a go at calculating the remaining 5 data points in our 3-point moving means table. Press play again when you're ready to see the results and continue with this question. By now you will have attempted filling in the remainder of the 3-point moving mean table, and we can see the completed table up here. And I have no doubt that by following this process, you have been able to complete this table accurately. Now you'll see on the board here, I have started preparing for the second part of the question, which is comparing the information by plotting both sets of data on the same set of axes. So I've started creating my axes here, whereby I have put time on the x-axis, and to help check my size for time, I looked at my smallest value and my largest value, so I know that this x-axis has to run from 1 to 9. Then having a look at my y values, this is where I'm going to put the sails. Now, when thinking about how large to create this y-axis, I always take into consideration the raw data. This is because the raw data will contain the smallest and the largest data values. The 3-point moving means won't ever be the smallest or largest. So I can see that my smallest value is 32 and my largest value is 80. So my axis needs to reflect this smallest and largest y value. You can see to assist with my scaling, I've actually started my y-axis at 30, but I've got a small break in here. This is appropriate for time series data, especially if your y values start quite a large distance away from 0, and that it's just not appropriate visually to graph them from 0. So I'm going to start off now by firstly plotting my raw data. Now, because we are wanting to plot these on the same set of axes, it's important for us to include a little key just to the side of our time series graph so we know what the data is representing. So for each of them, we're going to have a look at our week, remembering that's our x value. We're going to start with 1, and then our sales, remembering that's our y value at 32. So we would just put a point like this. You can use a dot, you can use a cross, whatever works for you. And we are then going to repeat this process for each of our data points. Now, depending on how you are completing this, using grid paper is recommended, as it's going to be significantly more accurate than what I'm doing without any lines. So let's plot these last few points. So once we have those data points completed, we are going to be connecting them with a straight line. So going ahead and joining all of those points with a straight line, remembering to join them from left to right. Okay, and there is our raw plotted data. Now, if at this point in time we were asked to comment on the data, we might not really have much to contribute. We can see a few quite low points of the data, but also a few quite high points. So where we might guess there's an overall positive trend, it's a bit challenging for us to see. So we're going to go ahead and plot our smooth data. Now I'm going to use a different color to plot these. However, if you're working with the same color, an easy way to vary it is to just change the point style that you use. So as an example, you might change from dots to crosses to help provide a contrast in your graph. So we're going to do the same process as we did with our raw data, but this time our week will still be our X, but our 3-point will be our Y. Also remember that the first data point is not going to start here at week 1, it's going to start at week 2. So let's go ahead, complete the same process for our 3-point moving mean. So 3 is 47.7, 4 is 50 here, 6 is 54.7, 7 is 66.5, 7 is 68, 8 is 66.7. Okay, now we're going to plot these points. So now we have our second set of data on the same set of axes in our blue. And I think it's safe to say that we can see much more obviously an overall positive trend for this data. So for the question, if we wanted to comment on the overall trend, we can say with certainty that thanks to the 3-point moving mean, this is an overall positive trend. So that's a quick look into how we can smooth our data using the process of 3-point moving means. Happy solving! Let me know in the comments below how you went with your smooth data problems, and hopefully your graphs ended up a little bit more accurate than mine. Also let me know if there's any other video topics that you would like to see covered.